It's September 8th, Tuesday evening, and your pre-calc homework for tonight is to watch this video and take notes. Take it in your comp book. 13 is still the page number, maybe 13A, B, C, etc. We will title this section Radian Measure. If for some reason you don't have your comp book, just take the notes on a piece of paper and we'll get it into your comp book in the morning. I assume we have had Radian Measure before, but I will teach it as if you haven't had Radian Measure. So let's see how I can get the best view on this paper. Alright, let's begin with what a radian is. Draw a circle and draw the radius to the circle in this position, like that. We call that a radius, and if I was going to pick it up like it was a piece of thread and lay it on the side of the circle, here I call it a radius, but when I lay it on the circumference or perimeter of the circle right there, I'm going to change its name. It is no longer a radius, it's now a radian. So the same length placed in a different position on the circle is called a radian. So this radian can, let's see if I take half a circle. So I cut that in half. So from here to here is half a circle, 180 degrees. I was wondering, and I'm sure you are as well, how many radians would fit in half a circle? So if I picked this one up and laid it again end to end with first one, here would be my second radian, and the third, if I'd drawn it correctly, proportionally. Circles are hard to draw, so if you have a keen intuition or a keen eye and a good circular circle, you will notice that a little more than 3 plus, we'll say, radians equal 180 degrees. And in fact, 3 plus can be narrowed down more precisely to 3.1415, etc. radians equal 180 degrees. And no surprise, this can be even more precise. It's the number pi. Pi is an irrational number, and it never, its decimal representation never ends or repeats. So it is interesting that many radians, pi radians, equal 180 degrees. We're going to use pi radians equals 180 degrees to come up with 2 unit multipliers to help us change from radians to degrees and back. So whenever you have 2 things that are equal, you can put one of them on the top, and I'm going to actually write out the word degrees just for emphasis, and pi radians on the bottom. So what does this equal? If I divide 180 degrees by pi radians, it is 1. So that's why we call it unit. Unit means 1, a unit multiplier. And the same if I put pi radians on top and divide it by 180 degrees. What does this equal? Anything divided by its equivalent is 1. So when I multiply by it, I haven't changed anything. When you multiply by 1, nothing really changes. The value doesn't change, but the form will. So let's say we were changing 30 degrees to radians. So I'm going to multiply. Let me again write out the word degrees. When I write 30 degrees, both the word degrees, the unit degrees, and the 30 is in the numerator. And it's understood that a 1 is in the denominator. So I'm going to multiply that times one of these unit multipliers that I talked about over here. So I want to take the one which will cancel degrees and radians will show up. So it's going to be the one where degrees is in the opposite place. It's in the numerator here, so I'm going to grab the one that looks like this. And that's pi radians. And you cross out the degrees, and 30 goes into 180 6 times, so reduce that way. I end up with pi in the numerator, 6 in the denominator, radians. So 30 degrees equals pi over 6 radians. I can represent circular, I can represent distance around a circle in degrees or radians. The reason we changed to radians is many principles in pre-calculus and above mathematically in higher courses will only work in radian measure. So radians will probably be the way you actually think in a circle by the end of this course. Alright, let's go the other way. Say we have 2/3 pi radians. So we already have a measure in radians and we want it back in degrees. So this time I have a 2 and a pi and the unit radians in the numerator and the 3 is in the denominator. So I'm going to multiply that by a form of 1. The unit multiplier this time has pi radians in the bottom and 180 degrees in the top. And the radians cancels, and the 3 will go into the 180 60 times, and I have 2 pi times 60 in the top, which is going to be 120, and the radians has canceled and degrees remains. So this tells me 2/3 pi radians is the same as 120 degrees. So with that in mind, we can take what we knew about the circle. Remember all the degree measures: 0, 90 degrees, 180, 270, and all the ones in between. We can replace them with radian measure. So in radian measure, 0 degrees, I'm going to put alongside of it, the radian measure is 0 as well. 90 turns out to be pi over 2. 180 is pi radians, and 270 degrees is 3 pi over 2. And you could verify that the way I taught you to go from degrees to radians. So I might ask you, remembering this is quadrant 1, 2, 3, and 4, I might ask you a question like, what quadrant is 6/5 pi? So if this is pi over 2, that means 1/2 pi. This is 1 pi here, and this is 3/2 pi. Where does 6/2? So again, this, I'm thinking in my head, here's my little thought cloud. This is like 1/2 pi. Pi over 2 means 1/2 pi. Just pi is 1. There's 1, and the 3/2 pi is 3 over 2. So, and back over here, 0, after 0, this can also be called 2 pi. So I'll put that 2 in the thought cloud. So I'm asking myself, where does 6/5 fit in what section? Here we go from 0 to 1/2, 1/2 to 1, 1 to 3/2, and 3/2 to 2. So where does 6/5 fit in? Fractionally, we look at the fractions, and 6/5 is greater than 1. Is it more than 3/2? Well, what you can do with your fractions is just continue your thought cloud and change 3/2 to 6. 2 and the 6 goes 3 times 3, it's 9/6. Oops, I'm sorry, I need to work in fifths. I want to change it to fifths. So I can't change 2/2 to fifths, so I'm going to have to work in the common denominator. The least common denominator is tenths. So I'm going to change this to tenths and this to tenths in order to compare them. 5 into 10 goes 2, so 6/5 is 12 tenths. 3/2, 2 into 10 is 5, is 15. So we see that actually 6/5 comes before 3/2, so it must fall within the third quadrant. So I might ask you to do something similar to that. Sometimes they ask, in what quadrant is -3? And that seems like an odd question because I don't see any pi, I don't see a degree. And I just wanted to explain that in that when there's no symbol, it's understood to be radians. And the negative means you're going to go in the opposite direction. So let me write a fresh chart here. So we have pi, we had pi, it was 0, radian measure 0, here it was pi over 2, pi, 3 pi over 2, and now I'm looking for minus 3 radians. So where would that fall? When it looks like this and you don't have a pi, they're working in pure numerical numbers. So if you actually put pi into your calculator and divide it by 2, it comes out to about 1.57. And pi, you know, is 3.14. 3 pi over 2 is 4.71. And then we can go back to 2 pi, which is 6.28. And negative means we're starting at the same starting point, but we're going the opposite way. So, and I'm going to have to recognize going in the opposite way, I've gone 1.57. I'm grabbing the number from up here, even though I'm going down here. When I go in this direction, I've gone 1.57, then I've gone 3.14, but I want it negative 3. So this is 4.71 is the same as negative 0.157, just in changing directions, and this is the same as negative 3.14. So you can see negative 3 is going to fall again in quadrant 3. In between negative 1.57 and negative 3.14, negative 3 would fall. So once again, the answer is quadrant 3. They won't all be quadrant 3. Alright, I'm going to turn off this video and make the second part. And I want to check and see if this part is showing up. And you can join me in part 2. See you then.